In this presentation, we'll be looking at connected rates of change. Grade E students will be able to state that the rate of change of y with respect to time is to y by the t. Grade C students will be able to use the chain rule to find connected rates of change. Grade A students will be able to find connected rates of change in different contexts. Section 10. Connected rates of change. Page 25 of the C4 notes. Rates of change are important within science, engineering and economics. The radius of a spherical balloon increases at a rate of 0.2 meters per second. Now, the rate of change of the radius, if we call the radius r, is dr by dt. So dr by dt is equal to 0.2. We're given a formula for the volume of a sphere in part A, which is 4/3 pi r cubed. So from that we can find the v by the r by differentiating, multiply by the power, which is 3, gives 4 at the front, take 1 off the power, 1 off 3 is 2, so we get 4 pi r squared for the v by the r. But we want the rate of increase of the volume which is in respect to time, so we want the v by the t. By the chain rule, that's equal to the v by the r times the r by the t. So 4 pi r squared times 0.2. This is 0.8 pi r squared. We want the rate of increase when the radius is 1.6, so when r is 1.6. So we stick 1.6 into the formula. And then we use a calculator. So we get 0.8 times pi times 1.6 squared. And to 3 significant figures we get 6.43. Part B is the same sort of idea, but we're using surface area instead. So dr by dt is still 0.2. So we start with s equals 4 pi r squared. We find ds by dr times by the power, we get 8. 1 off the power, 8 pi r. But we want ds by the t, which is ds by dr times dr by dt, so 8 pi r times 0.2, which is equal to 1.6 pi r. We want ds by dt when r is 1.6. So ds by dt equals 1.6 times pi times 1.6. Looking at using a calculator, we get 8.04 to 3 significant figures. Given the area of circle A is related to its radius r by the formula a equals pi r squared, and the rate of change its radius in centimetres per second is given by dr by dt equals 5, find dA by dt when r equals 3. So we're starting with a equals pi r squared. So we can find dA by dr by differentiating. We get 2 pi r. We want dA by dt, which is dA by dr times dr by dt by the chain rule. So 2 pi r times 5, given that dr by dt is given in the question. We get 10 pi r. We want the answer when r equals 3. So dA by dt equals 10 times pi times 3. Gives us 94.2. So 3 significant figures. Or if we wanted exactly, 30 pi. The volume of a hemisphere, that's half a sphere, is related to its radius r centimetres by the formula v equals 2/3 pi r cubed, and the total surface area S is given by the formula S equals 3 pi r squared. Given that the rate of increase of volume in centimetres cubed per second, dV by dt equals 6, find the rate of increase of the surface area ds by dt. Now this one's a bit harder than the previous examples, being that we're going to have to work backwards first of all. So we've got dV by dt, but we should also know from the chain rule that it's equal to dV by dr times dr by dt. Now we have that v equals 2/3 pi r cubed. So dV by dr is equal to 2 pi r squared. So sticking what we do know into the formula, we get 6 equals 2 pi r squared times dr by dt. So dr by dt equals 6 divided by 2 pi r squared. And we can cancel that down to 3 over pi r squared. And that gives us dr by dt. Now we want the rate of increase of surface area, ds by dt. We've got a formula for S. So S equals 3 pi r squared. So differentiating ds by dr, 3 times 2 is 6. So we get 6 pi r. ds by dt equals ds by dr times dr by dt. And it's the fact that we needed that dr by dt that meant we had to use the volume work to find dr by dt here. But ds by dt is 6 pi r. And in this case we're just wanting a formula. So 6 times 3 is 18. The pi's cancel. And r divided by r squared gives divided by r. So ds by dt is 18 over r.